In this particular problem, if we desire to integrate the function e to the x squared dx, this is one of those functions that has no antiderivative because it's not the derivative of any function that we know of. So this particular problem, with the x to be integrated first, x going from y over 2 to 1, and y going from 0 to 2, is not possible. But from this set of limits of integration, we can discern that the region is this one. If x is y over 2, then our y would be equal to 2x, and that would be this line right here with slope 2 through the origin. And the other limit of integration is x equals 1, and that would be this vertical line, x equals 1. And so this yellow region is our region of integration. Now what we're going to do is switch this in such a way that we can integrate with respect to y first. And so this is the exact same region described. So, but now if we integrate with respect to y first, the bottom on y, if I drew a line stripe across this, the top of y is 2x, the bottom of y is the x-axis, so that's y equals 0. So I'd be integrating from y equals 0 to y equals 2x. And the x values would be going from 0 here, where these lines intersect, and 1, where this vertical line ends the region. So these are x limits, x going from 0 to 1, and notice that I switched the order of integration. Well, we can integrate this with respect to y because this is just a constant with respect to y. And so we would get, integrating that, we get y, the integral of y times e to the x squared, y going from 0 to 2x. And so that's not too tough for us to do. Actually, that's quite simple. And, pardon me, I just got too many parentheses in there. And so, put in the 2x, we get 2x times e to the x squared. Put in 0, of course, we just get 0. So what we need to integrate now is the integral from 0 to 1 of 2 times x times e to the x squared dx. Well, that's easily done with the u substitution. Let u be x squared, then du is the 2x dx. And further, so I don't have to substitute back x limits at the end, I'm further switching the limits. When x equals 0, u equals 0. When x equals 1, u is x squared, so that's 1 squared, which is also 1. So what I'm really integrating is just integral from 0 to 1 of e to the u du, which I think anyone can see comes out as e to the 1 minus e to the 0, and of course e to the 0 is 1. So the answer for this problem is e minus 1, and we did it by switching our order of integration. Instead of integrating with respect to x first and then y, we fixed it so we integrated with respect to y first and then x, based on our redefining the limits of integration based on this region R.